So I want to work two mass abundance problems for you. The first one is calculating the atomic mass, and then the second one will be finding the percent abundance for two different isotopes. So remember, whenever we're thinking about these problems, two ideas are really helpful. The first idea is thinking about just weighted averages, right? So if we look at this problem, we see that 75% of the naturally occurring chlorine is from chlorine-35, and 24% is from chlorine-37. So this is saying, if we think about this in terms of pieces of a whole, that the majority is going to be from chlorine-35, and less so is going to be from chlorine-37. So whatever our final answer is, it's going to be closer to 35 than 37. It's going to be a helpful way for us to check ourselves. And remember that when we calculate a weighted average, we take the percentage, and since percent, right, is times 100, we're going to divide whatever percent we have by 100 so that it's a proportion or a fraction. So when we set this problem up, we're going to say that the average atomic mass is going to be equal to the fraction that is from chlorine-35, so 0.7577. We're going to multiply that by the mass of chlorine-35, which is 34.97 AMU. Then we want to add this to, I'm going to make this smaller. So you want to add this to the fraction that's from chlorine-37, so 0.2423 times 36.97 AMU. So our average atomic mass will equal 35.4546 AMU. Now we need to check for sig figs. So we're limited here by the significant figures in the atomic mass numbers. So there's 4 significant figures. So our answer can only have 4 sig figs. So therefore we'll have 35.45 AMU. And we're going to check our work. Is this number closer to 35 than 37? Yeah, so we should be feeling pretty confident in our work. So the next problem is going to be about finding the percent abundances when we know the average atomic mass. Alright, so this time we have boron. So we have boron 10 and boron 11. We're given the average atomic mass of boron, and then we're also given the mass of boron 10 and boron 11, and we want to find the percent abundance for each one of these isotopes. So the thing that we have to remember is that the fraction of boron 10 and the fraction of boron 11 are going to add up to be 1. So when we set this problem up, we're going to say the average atomic mass, so 10.81 AMU, is equal to the fraction of boron 10. So let's just call that X since we don't know it. That's what we're trying to find. So it asks for percent abundance. So percent abundance is the fraction times 100. So X times 10.013 AMU plus Y times 11.009 AMU. And we know that X plus Y, those two variables, right, have to add up to 1. So we can rearrange this equation to say X is equal to 1 minus Y. We can substitute this in for X, and now we can solve this problem. So I'm going to sub it in for X now. 10.81 AMU is equal to 1 minus Y times 10.013 AMU plus Y times 11.009 AMU. So the next step is to distribute this 1 minus Y. So I'm going to rewrite this. 10.81 AMU is equal to 10.013 AMU minus 10.013 AMU times Y plus 11.009 AMU times Y. So we're going to collect the like terms. So this term and this term are like, and then this term and this term are like. So I'm going to say 10.81 minus 10.013. I get 0.797 AMU on the left-hand side is equal to 11.009 minus 10.013, 0.996 AMU times Y. Now we need to solve for Y. So we're going to divide each side by 0.996. So 0.797 divided by 0.996. Let me make all of this smaller. So we have Y equals 0.8002 AMU. Well, actually, AMU cancels out. We can erase this. Okay, so we have our value for Y. Let's just do sig figs right now. Since the average atomic mass of boron is 10.81, that's only 4 sig figs, so we have the correct amount. So we want to represent this as, the fraction or proportion, and we need to represent this as percent abundance. So in order to get it to be percent abundance, we need to multiply it by 100%. So we have 80.02%. Okay, so that is the contribution of boron 11, right? And so we need to think about the contribution of boron 10 now. So for boron 10 is X. That was what we let that variable be. And so in order to solve for X, we can just say 100 minus 80.02%, 100% minus that. And we get 19.98%. So boron 10 contributes 19.98%, while boron 11 contributes 80.02%.